just give it one more minute for people to trickle in, then we'll get started. All right, let's get going. Welcome everyone to the TLS session for the week. Lovely to have you here to talk about all the great things related to TLS. Yeah, this is the note well. If you've been in meetings earlier in the week, you may have seen this already. This just notes your obligations regarding contributions and IPR related things, and also just how you should engage with others. In general, please be respectful and courteous to others when in the mic line, and we should have a pleasant and productive meeting. As usual, we need a minute taker and a Jabber scribe. Fortunately, we have both, thanks to Jonathan and Rich. Don't have to do anything with blue sheets, thanks to technology doing this automatically for us, which is fantastic. And hopefully we can keep doing that in the future. As a reminder, when you are in the queue, to say something at the mic, because the people who are taking notes may not be looking at the queue line, be helpful if you just say your name so that we can capture that accurately in the notes. Don't have to state your affiliation or whatever. Here's our agenda. We're going to have 3 presentations on active working group documents, CTLS, the hybrid key exchange doc, and then ECH. And then we'll finish up with a number of new or returning individual drafts that are potentially up for consideration in the working group. Before moving forward to talk about document status, does anyone have any comments, suggestions, or anything that they could change in the agenda here? All right. So here's a quick update as to where we are. Finally got 8996 out the door, so thanks to all who were involved in that effort. Short or not far behind it in the RC editor queue, we have ticket request, DTLS 1.3, and the connection ID draft. Those, thanks to DTLS 1.3 finally moving forward, this should free up a lot more space for other things that the TLS working group is producing. So expect to see them at some point in the near future. We have a number of drafts that went through the working group last call process, but we need revised individual drafts, specifically the export authenticators and the external PSK importer draft, both of which are just blocked on people making those changes. And we should poke the people who are responsible for those changes, among others. So we'll do that and then hopefully move them forward to the ISG. We also, after, I can't recall exactly when, but the external PSK guidance draft, which was meant to kind of go alongside the external PSK importer draft, we requested publication for that. And now it's just sitting in the ADQ for review, which I'm sure will happen shortly. We have a number of other drafts sort of moving along as well, specifically delegated credentials and deprecating MD5 and SHA-1. I don't know, Sean, if you want to say anything specific about the MD5 SHA-1.
So the MD5 SHA-1 draft, there was one outstanding comment. Daniel was nice enough to go back through his email and say which ones are resolved. And so there was one outstanding comment, which is whether we should remove some text through the updates that we're doing in this draft of 5246. It's on the list. Take a look. The delegated credentials draft is stuck on me reviewing Daniel's response. I'll get to that shortly. Back to you, Chris.
Thanks, John. We're also expecting most likely a change or an update to the DC draft that includes some test vectors for people who are hoping to do some interop. So expect to see those two things shortly. We currently have in working group last call 2 related drafts. The working group last call is ending at the end of this week. So if you've not already reviewed them and left comments, we would greatly appreciate it if you did so. That is the TLS flags extension draft and the cross SNI resumption draft, which is really quite small now that it just simply adopts the TLS flags extension and uses it as the the first item in the registry. Ecker, do you have a question?
3, but whenever details 1.3, whenever people want to hear it.
Sorry, the first part of that cut out. Can you say again?
Sorry, I said no. I was going to make a comment about details 1.3 whenever people are ready to hear it.
Yeah, feel free.
Yeah, great. Yeah, so I just wanted to flag that we got a comment from thanks John Matson and I think Magnus as well about like that it's unfortunate that the epoch number is so short. So I think there are a couple possible approaches to fixing that in details 1.3, but I think we probably should fix it. So I think that but like, I regret that I did not have time to do that for this meeting, but I have a couple thoughts. So I'll put foot in those issues soon, but hopefully we should just be able to like circulate by the working group quickly. Roughly speaking, I think the answer, I think the most likely answer is just to make the epoch longer and then either extend the fixed part of the EAD or truncate it. The truncating. So I think like we would need analysis of both of those, but that also should be pretty straightforward.
Okay.
Sorry,
right. Thank you for. No, it's fine. I had completely forgotten that was.
No, I mean sorry for missing it.
Oh, not your fault. Yeah, there's we'll once we figure out a resolution for that, we'll likely do a quick short working group last call just to make sure that it gets the additional review that it needs, and then move it forward from there. So we'll work with Ben and the ADs to make sure that it's parked in the where it is right now and doesn't move forward without this particular change. All right. Ecker, do you have anything else, or? Okay, I'll just take you out of the queue. And then as far as in progress drafts, we have the usual suspects, ECH, Compact TLS, and A446 Biz, hybrid key exchange, and then the return reachability check for 1.2, 1.3. We're talking about some of them today, and others are just sort of slowly making progress on the side. Sean, Joe, am I missing anything, or is that fairly complete?
We do have one expired draft. David Benjamin had a draft, I guess, that was RSA related that kind of expired. So we'll have to loop back with him to see if he's still interested in reviving that and moving it forward. And we've had a number of drafts that we've kind of talked about that are related that haven't really made it in because we're trying to get rid of details 1.3 and others. So maybe we can revisit bringing those back on. I know Jonathan Hoyer had a draft that we were thinking about trying to get adopted. So we'll kind of still have a couple in the wings that we're thinking about filling the queue back up in.
Okay. And if we're missing anything else, please let us know, and we'll get on that as best we can. All right. With that, I think we can jump over to the first presentation, CTLS. Ecker, will you be giving the presentation?
Yes, I was planning to. Though I'm a little unclear on the mechanics.
Like, how do you do the slides?
Yeah.
So I'm going to stop sharing, and then there's a button in the top left to share preloaded slides or join the slide queue. I don't know exactly what it says.
I don't. Maybe no. I see detached chat. If someone can tell me what it looks like.
It's right next to the hand to join the queue.
Oh, okay, got it. Ask to share slides. I'm asking to share slides.
Yeah. Grant preloaded slides.
Sharing, outstanding.
Awesome.
Thanks for your time.
All right.
Okay,
take it away.
So now that like DTLS is allegedly almost done, I can turn my like less than focused attention to this topic. Oh yes, it is Comic Sans all the way, Chris. Yes. Next slide. I don't know why I have the stupid wrong title because this is like draft IETF, whatever, but whatever. But we can ignore that part. Next slide.
You,
me, it's me,
so you
isn't
actually
it?
control it yourself. Yeah.
That's me. I know if I just say it, should have happened, right? So okay, right. So we did a 03 update. This is like large editorial. And the idea was to focus really, as we sort of got our experience with this, to focus on the template-based specialization and in particular the DH-based handshake, because that's where most of the value proposition is. Important to recognize, and I think that's something that we're getting better about, is that the template system itself is generic. So like we don't have to get every specialization keyword in now. We just have the system in place, and then because the way to think about this is a template that says like if you have this template system, then you can like remove this piece or shorten this piece or whatever. And so like you can perfectly, and since both sides have to agree on the template anyway, you can just add new keywords. Right. I think, so nevertheless, there are a few issues I want to discuss, at least briefly. I think the first is the variant encoding. I think when we first did this, before we sort of invented the template thing, we had this variant encoding, which is hoping to save some space because like TLS is a bunch of situations where, like you're encoding, a length of 24 bits, even though the thing can only be like 1 octet long or something. Or in practices, but it doesn't actually, and also I think there's a sort of sense that this was a crufty kind of encoding. But like it doesn't really see that much space, and it's really a hassle of a TLS stack which does both, especially in places where especially in places where you don't have like functions that do that work, and even many stacks like in some places have like functions which do the work, and in some places kind of like do a0 left shift 8 plus a1. So I think we're proposing to remove this. And just like live with the fact that TLS does slightly cruftier encoding than Quick does. I guess I'd hear anybody who really objects to this speak up, and if not, I'm going to do it. Patton?
Yeah, I don't have an objection. And I haven't thought much about this myself, but I was curious if folks really do plan to put this in the same stack as their normal TLS stack, or would this be a totally different, would this be a totally separate thing? I guess is my question. How do folks imagine implementing this?
Well, yeah, we think about this. Yeah, so as Hannes was saying, he worked on the code and it was really hard. I think one way to think about this is that like one definite way we're thinking at this conceptually is a compression layer below TLS, and in that case, it would be the same stack. And in any case, because you reconstruct the transcript, you have to have both sets of encoding. So, okay, hearing no objection, I'm going to go ahead and do it. If someone could note that for me, that'd be helpful. Okay. Next slide. Just saying it, but here it is. I think we've known for a while that you can do much better with semi-static Diffie-Hellman than you can in terms of bandwidth than you can with digital signatures. The signatures are bigger. You can replace the signature with a MAC, and in some cases, maybe you can get away without even the MAC. 1.3, as people recall, focuses on these sort of Sigma style modes. But there's been a bunch of talk about OPTLS DH style modes. The good news is that there's already been work on this, and we in fact have a accepted draft on this, which we're just like not doing very much on. So CTLS can just pick this work up immediately as soon as it's done. So like while I think it'd be good for CTLS to have this functionality, we can do it separately. And I'm like, as you can see from the rest of the presentation, I'm a big fan of doing everything separately. So this has been floated that we should add this to CTLS, but I don't want to, unless somebody like really is going to argue for it, because like it just slows things down. And if you do, I think it's very important that you should help us with draft semi-static. Okay. The second thing people suggested that we do, which also would improve the situation, is point compression. As people recall, for the NIST curves, we use the uncompressed mode. This is compatible with what everybody's already doing, but it wastes some space. Martin asked the proposal to make a CTLS extension, and I assume you're talking about semi-static. No, there's new cipher suites. So So like basically what happened would be as soon as you had like CTLS for TLS 1.3, which is sorry for TLS 1.3, it just work for CTLS in the usual fashion. As far as so going back to the point compression, these uncompressed curves like waste 32 octets or whatever it is. Yes, David Ben, exactly. I should stop reading this chat. So they waste the y coordinate, right? So everybody knows this. But the good news is that once again, this is like, thanks to like negotiability, this is straightforward. All you have to do is like add new points, new code points and named groups for for NIST P256 compressed. And if anybody wants this, it's easy to do. So anybody who is like excited about this, please write an RFC or a document that is like registering those code points. So again, I don't think we need anything CTL specific. And of course, this is not necessary for the 25519 for the CFRG curves, which already only encode the x coordinate. Okay. Now I come to like two things which actually do matter. And let me get like ahead of these by saying what I said at the beginning, which is that I think it's important to break out the idea of specialization and the sort of basic specializations you need from everything you ever want to do to make TLS 1.3 CTLS smaller. And so what I'm going to propose here and in the next slide is that we don't do anything, and then or that we in parallel look at analysis, and if this analysis pops up well, then we can add specialization keywords, and if not, we don't have to. We can do it later. So to recap this, so to get back to this particular point, the TLS 1.3 handshake is designed in such a way that does not require the record layer to deliver security, right? Namely, the finished messages provide a MAC of the entire handshake. And so this gets called like UC or CK security, but the idea being that you don't have to make any assumptions at all about the record layer, and you can just guarantee the handshake. You run the handshake at the clear, and be sure you'd negotiate it properly. Of course, let me just be clear, you would not, of course, be protecting the things you're supposed to protect that are in the handshake that are supposed to be secret, but you would have the cryptographic guarantees of negotiation would be correct. No, we don't, John. But the fact that we do run TLS 1.3 and CTLS over an encrypted transport and encrypted record layer means that the finished messages have two integrity checks on them. They have the one that's in the finished message itself, and then they have the AED authentication tag. And so analyzing this case is somewhat hard. And so one of the reasons we didn't do this in TLS 1.3, and so the point being that in some protocols simply omit that final integrity check. And they say, like, I'm relying on the record layer to guarantee that things are correct. And you can either do this by having, like sending an empty message, or you can do this by having it be that the first, the first data message guarantees handshake completion. In any case, this is not like, making this change is not straightforward, and Chris Wood just posted some analysis in the chat that indicate that like you actually have to work very hard to convince yourself this is okay. So while it may be possible, I don't think we should do this today. And the good news is, if we were to do this, it's simply a new keyword that says like emit finished. But it's like technically it's easy, but from an analysis perspective, then you have to be able to restate what the analysis guarantees are. And there's something like, once you get the first application layer data message, then you know things are okay. Oh, and this does not guarantee that anti-downgrade in a case of catastrophic failure of the record layer. So that's actually probably the second important point, which is, imagine you had like a record layer with a really, really like weak authentication tag. So you said like, I was only willing to live with like a 32-bit authentication tag. Now it's not clear what the security of the finished message is, because that would be the guarantee. So that would be the guarantee of the handshake, right? Yeah, as Martin says, CCM4. So scoping this out is difficult. And so I propose not to do this today because I want to get CTLS done. People who are enthusiastic about this, I propose we get some analysis and maybe we can get analysis of this in case of TLS as opposed to in case of WireGuard, which is the link Chris posted. And if that comes up okay, then we have a straightforward proposal either to drop right into the draft as a new keyword or for a future draft. Hoyland.
Could you just expand a bit more on why you think that we don't need the record layer for post handshake auth? Because when we did our initial analysis with Tamarind, we showed that post handshake auth messages can be reordered except because of the message layer, record layer.
I think you're correct. They can be reordered, but I'm not sure what that gets you.
We came up with an attack.
Okay, so it's quite possible. Okay, so I may be being so that's an interesting point. So I think reinforces my point about let's not be hasty. But bear in mind that I am suggesting removing the finish, not suggesting removing the EAD. But yes, I think it's entirely possible that it's not safe to remove the finished in the post handshake, but it is safe to remove it in the handshake. So so I think I think this is why I'm want to be cautious here.
Sounds good.
Okay. Next slide. Here I'm just doing it myself. Right. The second thing that place of big wastage is the random values. So CTLS random TLS 113 random values are incredibly long. They're 32 octets. Now it's true that we use a bunch of that for random signaling of various kinds. So just removing them isn't totally straightforward, but it's potentially possible. If you read the original Sigma proofs, they actually assume there's no nonce because they assume the Diffie-Hellman shares are fresh. So there's some precedent for removing them. But then you also read the Sigma paper, and he goes this is a terrible idea, so don't do this. And real protocols have nonces, right? It's been proposed to remove this, but I think that and as I say, there are protocols that don't have this. I say Chimera WireGuard being one protocol. But I think for TLS, I'd want to see much better analysis before I was comfortable removing this. And again, you can there's the version where you just say there's no random. There's a version where you hash the Diffie-Hellman values to call it the random or whatever, but they're all the same kind of property. There's no fresh entropy outside the random. It's also really important to mention that for zero RTT, of course, you can't do this because unless you're definitely putting Diffie-Hellman values in, and so the whole thing gets really hard to reason about. So again, this needs analysis gets some. So if somebody could if people were excited about this, please send me papers. Okay, next slide here. I'm just gonna keep saying that. This is actually something Ben Schwartz mentioned on the email list, which is that we could do encryption for client hello and server hello a la quick. This potentially runs some ossification, for instance, NAT strip streaming perhaps. There's a number of possible ways to do this. One of which is having a fixed key, as in quick. One of which having a per specialization key, and one of which have an ECH-based key. It's not entirely clear to me which of these would prevent exactly what. I think they all prevent ossification somewhat, but maybe some of them wouldn't prevent NAT slipstreaming. I'm actually not entirely sure exactly how to. The NAT slipstreaming thing is actually a little complicated. I guess my question is anybody really excited about doing this and want to speak up for it? If so, can we see some PRs? And if not, can we not do it? Good. Thank you.
Hi, Ben Schwartz. Thanks for the slide. I guess I just want to ask, do you think that this is something that can reasonably done as a follow-up?
I think it could be, yeah.
Okay.
But I have to think about it. I have to think about it, but I think maybe.
Okay.
The profile ID is in the record header, so it's very early, and so you would be able to debug, I think.
No, you wouldn't be able to demux.
Okay, maybe you could take a look and come to your own conclusion.
Okay.
I'm not opposed to this. I'm just I'm just like not excited enough about it to like push it forward unless somebody else wants it.
Okay.
Okay. Sounds like we have a next step on that one. Oh, Patton.
I just wanted to raise my hand in support of this. I think this is a great property of Quick. I would be fine with a fixed key. I think it would be too complicated to try to use EC for this. Yeah, that's it.
Okay. Okay. Well, so I think as people will see from the next slide, I'm not proposing to like finish the working group last call like any minute. So I think we have a little time to think about it. So I guess Ben, hopefully you could take a look and maybe Chris give you a hand and we can come to some conclusions.
Sounds
okay. So next steps. Thank you, Wood, for filing the move variant. I'm going to do that. I think we'll spin a 104. I know there's been some work on implementation, so I'd like to get some implementations. Patton, did you want to talk, or you just didn't remove yourself? So I think like the next step, I think, is like for us to get those implementations in interop working. And I know Hannah's been working on something, and I know Richard and I've been working on something, mostly Richard. And then parallel, we can do these pieces of work that people proposed, and then just like race them to the finish. But I think like the feature set, I think the feature set is close enough to finish now that if we had like interop, we could just ship the thing. Okay. You know where the GitHub is in case you find things that I did not notice. Bye-bye.
All right, thanks, Ecker. Can you stop sharing so we can pull up Douglas's slides? All right. Okay, Douglas, take it away.
Okay, hello, I'm Douglas Davila from the University of Waterloo. I just wanted to give an update on the hybrid key exchange draft with my co-authors Scott Fleur and Shai Garong. So the motivation for this draft is to permit simultaneous use of traditional and post-quantum key exchange in the same handshake. The idea being that this would enable early adopters to get post-quantum security while still having the security that's present in the elliptic curve or standard DH right now. And we might want to do this because of some potential uncertainty on newer cryptographic assumptions, or the need to, the desire to use post-quantum while also keeping certification of implementations that use traditional algorithms before those certifications are updated. So the goal of this draft is to define data structures for the negotiation, communication, and shared secret calculation for this goal. But it is not a goal to do anything about hybrid or composite certificates or digital signatures or authentication, nor to select which post-quantum algorithms to actually use in TLS. We've had a draft up for a little while with the mechanism. It's a straightforward mechanism, relatively straightforward. Basically, the idea is that each desired combination of a traditional and post-quantum algorithm will be tagged as a new opaque key exchange group. And then to negotiate, these new named groups for each desired combination will need to be standardized. In terms of communicating the key shares, you simply concatenate the key shares for the two constituent algorithms in no clever way whatsoever, just straight concatenation. And similarly, shared secret calculation, you just concatenate the two shared secrets and use that in the existing TLS 1.3 key schedule. We considered a bunch of design options in each of these three parts of the process, and the draft has a much too long appendix that explores these, but we've selected the ones that I mentioned on the previous slide. So a couple of questions. We want to figure out what is required before this draft can advance because it's currently listed as a working group milestone for this November. One particular question that has come up is whether this document should include concrete named groups for the existing elliptic curves plus, say, the NIST post-quantum crypto round 3 finalists, so that people can already start working on interoperable implementations, or whether that should be left for a future work or for when round 3 has concluded. So that's the idea. I don't know how to do questions between the queue and the chat. Eric, did you have a question?
Question. So I'm attempt to answer your questions more accurately. I looked at this draft today, and it seemed like it was roughly what I was expecting. So I think we're probably. I would actually suggest we start. I would suggest unless somebody has like some objections now, we start working cross call, because like that's kind of how we force people to review the draft. And I know like probably I'd be more likely to really read it if I was working cross call myself. And it's not like it's not like unless we are aware of a bunch of open issues, like we're not like having a bunch of like quasi reviews that aren't like forced by that doesn't seem very helpful. We might consider removing a bunch of those dependencies, by the way, depending on.
Yes.
So in terms of your question, that would also let us hit November. In terms of your question about the groups, I guess what I would suggest is that we do some kind of informal poll, rather than sort of like the combinatorial explosion, that we do some kind of informal poll on the list of like who's interested in what, and like anything which has like more than one client or one server interested, we like do some code point registrations. We have a lot of code points to work with, so I think that will give us that'll give us the ones people actually need, and it's not like it's expensive to do code point registrations. So like if we miss one and then people get excited about like I don't know what psych with psych with X448 or something, I can just add it, right? So that'd be my suggestion.
Great, thanks very much. I'll try to follow up on the working group then with some kind of way of identifying what combinations people are interested in. Jonathan Lennox has a question in the chat. Does this only work for the pairing of classical and post-quantum algorithms, or could it work for other algorithms such as national algorithms? Yeah, the draft is completely agnostic as to whether they're post-quantum or not. In fact, I think the term is used as next generation, just to make it clear that it really can be any two combinations, combining any two algorithms you like. So there's no specific requirement they be post-quantum. That was just the original motivation.
Ludovic, if you're in the queue and still want to ask a question, just unmute yourself and should be good. If not, Douglas, I think you can move forward.
Okay. Oh, Sean has just come in.
No hat on here. I just want to make sure that it's very clear that if we start picking some, that we are not anointing a winner in any way, shape, or form. We have to make sure we put all kinds of caveats all over this. Any kind of like parameters that we pick or anything need to get blessed by the CFRG. That this is merely just messing around to try to make sure that things end up being interoperable, and then when things finally get selected, that we go. Because when we first adopted this draft, that was one of the big questions was, well, what are we going to do? And we definitely don't want to be seen as picking a winner here. And now I'll let people that are actually cryptographers and implement talk. So thanks.
Yeah, no, I absolutely agree. And there's a tension between that. Stephen?
Hi, yeah, just echoing John's point. It might be worthwhile thinking about having some grease-like code points that we pick and document on a web page or in GitHub or somewhere for experiments, with the knowledge that those can never be the final answers, rather than just allocating code points now.
Okay, thanks, Nick.
Yeah, just want to second what Sean said. I don't want to, without going through CFRG, define code points for anything NIST related. And I would recommend using existing code points in the document.
Sorry, I'm not sure I understand what you mean by using existing code points.
For any examples or whatnot, you can combine existing algorithms as a demonstration for, say, test vectors.
Okay, gotcha. Understood. Thank you. Eric.
Slides, just press the wrong button, chairs. But I guess I didn't quite understand Nick's point. Nick, if I'm mischaracterizing you, let me know. Like, my assumption had been that we would pick the the sort of top, the most attractive of the ones that people actually wanted to do, probably some of which are in the NIST category, but that we shouldn't pick them just because we're in NIST, and that we should mark them not recommended, or recommended equals N, which is the thing we do for, like, we think it's maybe it's fine, maybe it's not, then once the finalists are approved, then we can send them through CFRG, and CFRG can bless whichever ones they think are appropriate, and then we can mark them recommended equals Y with basically with like a single document. So I think like that, then we'd be allowed to keep reusing the code points, which seems very attractive, and we'd just be marking how we think about them. But Nick, if I'm mischaracterizing you or you disagree, like, now's the time.
Yeah, so I was I was saying that we should probably, yes, use a reserved set of code points for things, but this document itself does not seem like the right place to define post-quantum crypto implementation algorithms. I think that should be a separate draft, likely one through CFRG. I would request, if this is something we should kickstart now, that some type of formal request from TLS to CFRG to look into that would be something we consider. But in terms of like defining a Kyber cipher suite and point in this document, that seems a little bit too much. Fine to do it in implementations and interoperability perspectives, and in this document, if there are test vectors to use existing code points. That's my suggestion, and happy to discuss further if you disagree.
So, Nick, if I understand what you mean by using existing code points, that would mean like a written example with X25519 plus NIST P256.
Yeah, or RSA.
Yeah. Okay, thank you. Ludovic?
Yes, do you heard me? So I was on mute before.
Yes, we can hear
okay,
you.
so you mentioned that you are not going to consider authentication, but still at some point we are going to solve this point. So what is the strategy? And so kind of related, so there is another proposal, ChemTLS, which is going to be proposed after. And so I wanted just to understand what is going to be the strategy, or if there is no strategy, it's fine.
Right. So the reason for considering key exchange prior to signature-based authentication is the concern about retroactive decryption, that a quantum computer could retroactively decrypt today's communication, but could not retroactively break authentication of today's communication. And so that speaks to focusing on post-quantum confidentiality before post-quantum authentication. As for comparing this with authenticated chem or ChemTLS, that is somewhat orthogonal. That's focused on authentication. This is solely focused on the ephemeral key exchange. Chris, I do see we have one more question from Watson in the queue, but I know I've gone past my time, so I'll defer to you whether you want to take another question or not.
Yeah, Watson, go ahead.
Question about, or I think Watson, real quick, the answer to the question about where we put these things is we have experimental code points for a reason. That's where we should decide that we're using Kyber at X25519, and I think it's fine for there to be text saying we're doing an experiment and here's the definition, and then later you change it to be like, okay, here's what we decided on, here's the final standard assigned code point.
Okay, thanks. I'll follow up on the mailing list asking for how to best approach this.
And we can assist Doug. We can coordinate with CFRG and security ADs if we need to.
Thank you very much.
All right. Time for ECH. Okay. Quickly start a timer. All right. So this is just an update on ECH, and hopefully a sort of, marking a significant milestone for the work group in this particular protocol. So just to give you a sort of quick summary as to where we are right now. After many iterations and updates over the past couple months between the last meeting and the interim, the document feels, or we feel as though the document's in a good enough place where one can implement it. Indeed, there are a number of implementations floating around that do interoperate to some extent. We are also not aware of any known security issues. This is thanks to, of course, the careful work of all the people contributing to ECH and its design, but also in parallel analysis has been done by Karthik and others at INRIA to demonstrate that the design with some slight changes, because it's a little bit out of date, is mostly safe and achieves the desired security and privacy properties. So at this point, we're kind of at a stage where, you know, any other decisions that we'd like to make, or, you know, features we'd like to add, changes, what have you, really kind of need to be informed by, or it seems as though they need to be informed by, you know, actually using this thing in the wild. And before kind of going into sort of the specific issues, I'd like to just upfront just say it's probably a good time now to sort of park this particular draft, maybe go through working group last call to, you know, iron out some of the editorial deficiencies or what have you, and then let it run for a little bit. And, you know, from that experiment or from that experience, come back similar to like what we did with TLS 1.3 and make any necessary changes. Sean, go ahead.
A quick question, because I know people are going to ask, how long do you think you'd want to let it bake for?
Really unclear. I think it depends on people who are interested in using this particular technology. So at the end, there's a proposal to just kind of revisit the next IETF meeting. It might be longer. I guess it depends on how, you know, what the timeline for baking actually is. I don't have any sort of expectation in mind, though.
Fair enough. Thanks.
Yep. Okay. So with that as the framing, there are a number of open issues, 3 sort of high-level ones that I'm going to talk about, 3 groups of open issues. The first of which relates to the acceptance signal. As a reminder, the acceptance signal is the thing that the server effectively says to indicate whether or not ECH was accepted and the inner client hello was chosen, or rejected, in which case the outer client hello was chosen. And there are 2 related issues here, 450 and 441. Basically asking the question as to whether or not the acceptance signal should move from its current location in the non-HRR path from the server hello random to an extension specifically in the server hello. And related to that, if we do continue using this extension, should we start greasing it? And so there's a number of different answers to this question. You could make both of these changes, in which case the HRR and non-HRR paths are sort of consistent. This potentially does, you know, run the risk of introducing or hitting problems with the server side server low extension as you turn it on. But the idea is that hopefully it hedges against some potential HR problems down the road when HR does occur. You could not do any of these changes, which would be what we have right now. And that potentially risks, as noted, you know, potential issues with HRR later down the road. You could do a mix and match, you know, take the extension, but then not grease it. That seems less ideal. And then the opposite, which is, you know, don't take the extension and grease. It just seems kind of strange, or there's little benefit to it. So I think the proposal I'd like to put forth is to not do anything at this point. Just park it and sort of, you know, run some experiments and figure out whether or not HR is indeed impacted and if we need to make a change. So I'd like to pause here and see if folks have any opinion about that. Martin, go ahead.
The no yes option isn't entirely crazy. It's the draft sort of doesn't really say much about this, but almost implies that you could put a garbage ECH extension in HRR, and that would be okay. But it doesn't really say what you do with it, and it's not quite right. But you could do that. So I think
could you
do this?
I don't know if it's others are experiencing it, but I'm having a really hard time hearing you. could you potentially type your comment? Or if someone else heard it and they could relay, that would be great. I'm sorry.
No, yes. So I guess my TLDR is I want to like stop screwing with this and run some experiments. And I think it doesn't actually matter that much what the contents of this particular thing are. I think to the extent to which the thing is like, if the signal contains bits as opposed to just being, so like I think the signal can be empty, but if it contains bits, then we have to define what's wrong, what happens if those bits are wrong. So I think no is like no bits, and no yes is it's got some bits and then they can be greased. So I think like I would suggest that like whatever the draft is closer to now is the one we do. And if we decide we don't like it, like we can change things later.
By
big
no
preference,
bits, you mean?
I mean empty extension. An empty extension.
Okay, go ahead. Yep.
I mean the point of the non-empty extension is to the point of the non-empty extension is to allow for greasing, right? And so if the extension is so the extension, so I think it's silly to have a non-empty extension that cannot be greased. But anyway, I see Carrick's here and David, so I'll step back.
Okay. Yeah, Carrick, go ahead.
So I was reading through all the comments last night on this, and it seems like it boils down to, I mean, to me, it doesn't matter. It's like irrelevant, like whether we do the extension or keep it the way it is. But the sticking point seems to be primarily on, do we think middle boxes are going to freak out if the server below has this extension, or if it doesn't, like our middle box is more likely to freak out if the HRR has this extension. And like, I don't think we like have enough data to answer that question. Maybe that's what Ecker was referring to in terms of like just doing the implementation and like seeing what happens. Because I just don't know. I don't know if we should bother to answer that question. Like, I mean, you could just say, look, they should be doing the right thing. It's their problem if they're not. But then again, you could say, well, it is our problem if they're not, if they're acting up. So I don't know what you guys usually do in terms of that. So that's my comment on it.
Yeah, thanks. And I agree. At this point, we're sort of, and to some extent, speculating what potentially might happen. So the proposal to do nothing, just implement what's there and try to run with it and see what happens in the wild will help inform the decision one way or the other. And it's less change at this particular point. So, David, go ahead.
Okay, cool. It's on. Yeah, so I think I agree we should just do like the minimal change. It's a little interesting that like no change is kind of halfway in between. So I think as Edgar noted, the grease question for the second question is mostly like how you define the error handling for those bits. And I believe this draft currently says that on the client side, you like if you see an extension with the wrong bits, you just kind of ignore it, which is no, yes. But on the server side, it doesn't say you're allowed to do that. So on the server side, it's no. And so we're kind of weirdly halfway in between the two. I think no would be the client should reject the invalid ones, in which case it's still giving you some value because it's the bits also prevent someone from forging an HRR when you wouldn't have done one, because the HRR sticks out a bit more than non-HRR case. And no, yes, I think would be we leave the client side as is, and if someone feels like it, we can add a sentence that says servers can go make fake values up if they want.
I whatever is the smallest change at this point, I guess, is where I lean.
I think we can also like defer adding the sentence and be like, it's in this halfway point. That's weird.
Yeah, Ecker.
It sounds like nobody cares very strongly, but everyone cares that it get done. So I suggest that we empower the editors to solve this in some way that is one of those two and move on.
Yeah, as with my chair hat on, I think that's the way to go. Since no one's trying to find a sword to fall on, let's do this. What's proposed here on the slide?
As I sort of said in the chat, I think we're gonna find like a lot of interrupt problems, and so like rather than trying to pre-solve all of them, I'd like just to get this out there and find some of them.
Yep. All right, so we'll take the action to resolve this one with the other and then follow up on the list. Chris?
Ecker, just to clarify, do you mean interop problems or middle box problems, or or do those mean the same thing?
I mean, I think first we'll find interrupt problems, or we just order the spec, and then we'll find middle box problems, and middle boxes don't like the spec.
I assume that clarifies, Chris. Okay. Yeah, so we'll take the action to resolve this and then fold it into the changes necessary for the next version. Should be good. Okay, next issue is padding. This is one we've been punting around for a while now, specifically server-side padding. There are two different proposals up for addressing this. One of which is to introduce a new handshake message specifically for the purpose of introducing padding during the handshake. Another of which is to use existing extensions use extensions on existing handshake messages for the purposes of padding. You could also just not do either of these and just apply sort of some default dummy padding policy out of the box using like TLS record layer padding or quick padding or what have you, whatever the context happens to be. There are, if you look at the issue and the relevant pull requests, there are a number of different considerations to take into account. David has done a lot of work talking with the integration between ECH and Quick, and there's some interesting caveats there to be mindful of. How the padding works in relation to certificate compression is also quite interesting, specifically whether or not padding is applied before or after compression. Yeah, and there's also considerations for what the impact on the state machine is, which is relevant for the new handshake message. And then there's also, if we're going to use existing, padding extension, there's potentially restrictions that were put in place from RFC 8446 or TLS 1.3 with respect to where that particular extension can go and how which party can send it and under which circumstances. So in general, padding has been sort of this thing that we've, not TLS specifically, but just sort of network protocols in general have tried to account for, but haven't quite figured out how to use it correctly or in the best way, for some definition of in the best way. DNS, for example, has this recommended padding policy that came out of dprive for using just like fixed block length padding. That was based on some analysis that DKG did with respect to what the average DNS query and response sizes were. Maybe something like that would work here, but my general impression is that we haven't quite figured out how to hold padding correctly in order to make ECH have maximal privacy in order to get the maximal privacy benefit that ECH promises. So in absence of that particular skill or what have you, I propose we do nothing at this particular point, specifically because as discussed sort of in the context of the previous issues, as we roll this out and start to do some initial experiments, we're primarily trying to figure out what the network interference is and what the network impact is, whether or not there's middle boxes that fall over and whatnot, and how padding is applied should not, for some definition, should not affect that. I mean, it may, but ideally it does not. Now, it's necessarily true that absent server-side padding, you don't have the the ideal privacy posture that ECH promises to have. There may be certain domains within behind a client-facing server that leak unintentionally based on the size of the server's flight. But for the purposes of this initial experiment, I don't think that's really necessary. So the proposal is to basically do nothing at this point, and then later on, once we see what these these handshakes look like on the wire, see what the impact is, maybe then we'll be more informed or in a better position to make a decision on how to address this particular problem. Acker, go ahead.
I'm getting sadly a little warmer to David's proposal, but not warm enough yet. And we can still do it out perfectly fine, even for Quick without solving this problem at all. So I'd like to just I'd like to punt this so we can argue about it for the next 6 months. And the good news I think is that if we were to precisely for the reasons that padding matters, if we were to add padding and it were to break anything, that would be surprising. It would be quite surprising. And so I think we should just move on and we can just figure it out in the next 6 months or so. It's going to take us at least this long.
Yep. Okay. Carrick?
I'm totally fine with just punting it until later, except that, if we're gonna have to deal with it anyway, it's like we might as well figure it out. I'm not really sure I see the total advantage, except unless you want to try it, because we can already interop now we already don't have padding. So also, I was reading through the extension PR, and it seems fine. I don't really understand what the objections are to it. It seems a lot more clear why it works or how it works than the message version. So I don't really understand why we can't just do that PR and be done with it.
Chris?
So I guess my only rebuttal to Carrick's point is the two proposals right now. We are either proposing we have an extension that the client uses to solicit server-side padding, or we define a brand new handshake message. Both of these things would make sense in my mind if they were in their own self-contained document that we depend on for ECH. I think that would be the ideal solution for whatever padding mechanism, something that's independent of this and that we just use. So for that reason, I think it's worth punting on this until that document exists. Others might think that's the wrong solution.
People's attention to the discussion in the chat where we have violent disagreement about exactly what the right approach is, and I think that's the answer to Kara's question, which is that we can spend the next 6 months arguing about how to do padding, or we can spend the next 6 months shipping and arguing about how to do padding in the background. And I prefer to do the second. That's my motivation.
Yeah, I think the intent here is just to try to not let perfection be the enemy of the good. It does seem like a separable problem to some extent. Not something we should not punt out of ECH entirely, but something that we can separate out for now and to get some initial experience with ECH, and then address it later on. This also gives us time to figure out how we will actually pad. Setting aside the mechanism, what the actual number will be, which is a deployment specific thing, and it's not clear that everyone has the answer to that. So my take is to just, as Ecker said, just punt.
So hey, Chris,
Sean?
this is Sean as chair. I think that's the proposal we should go forward with. I kind of feel Carrick's point, but reading the chat messages basically made me think that we should punt. So I think that's probably just the way to go forward, and we can just move on to the next issue. Thanks.
I mean, perhaps a proposal to help make sure that this doesn't languish indefinitely. After we sort of cut the next version, and that's the thing we target, potentially we could spin up a design team for folks who have very strong opinions about the particular padding mechanism, and they can sort that out and come back to the working group. I don't know how folks feel about that. Say it again.
I'm not worried about it languishing. I think it's in the issue tracker. If people feel strongly about this and they really want to get the padding thing resolved, then yeah, go ahead and convene a discussion. Then make a bit of a design team or something, and try to get the people who disagree on both sides come to agreement. That's the thing to do. Yeah, and I don't think that should be a formal thing until that becomes a blocker for us.
Sounds good. I'm happy with either way. Okay, so we'll just note in the issue we're parking it for the time being, and we'll revisit after the next draft and we get some experience. Okay, the last issue is on extensibility. Simple question: should ECH config be extensible? Sort of binary question. We don't currently have any extensions that are in use. There have been proposals in the past, and I think there's a proposal from Ben. For one, Ben Schwartz, but given that this potentially has value going forward, and there are some potential candidates, but there's also some objections to them existing entirely. and the cost of parsing extensions that don't exist is effectively 0 right now. I propose that we, like the others, just park this and revisit it later. Does anyone have any objections to that? Carrick?
I'm fine with that, but I am kind of concerned about, I think someone mentioned like a use it or lose it sort of thing. It's like if we don't do it now, it's going to be harder to do later. But if no one thinks that like is going to happen, then, fine.
Harder being like harder to remove later?
Harder to add later. Like if we don't have extensions now, like it'll be almost impossible to add them later.
I don't think that'll be the case. If anything, I don't know. I don't really have a strong feeling about this.
Okay.
Stephen?
Yeah, I think these extensions are useless. I'm okay with leaving them and parking this. I do have a question though. I did write a bit of code that could put any random file in to an ECH config at that point. So I'm kind of wondering whether we want to add language saying, please don't do that during the experiments. Or is everybody else writing code that won't fall over if you give it a cat picture?
That seems reasonable. Ecker?
Let's add that. Send some text.
Yeah, test with cat picture is great. Okay. So on that note, I think we'll just note this in the issue and then move forward. What that effectively means is sort of all the main technical open issues are either resolved or we're sort of parking them to resolve after we get some initial experience. Draft 12 is currently the published version. However, depending on how as discussed earlier, we will most likely make some small changes to address the acceptance signal text. In which case we'll bump a new version, potentially folding in some editorial changes that some people have contributed and move to 13. So I would propose that we move to draft 13. And as we start bringing up implementations, filling out the interop matrix, which is linked here, also linked from the wiki page onto the repository. Yeah, exactly, lucky 13. Does anyone have any objections to that being sort of the next interop target? It means we sort of like skipped over 12, but that seems fine. Okay, the dogs are sleeping. They don't really care about ECH. Right, so just to summarize, as I said, we're going to resolve some of these open issues or park them accordingly, noting in GitHub. I'll probably just introduce a new label just to note that they are sort of on hold. And hopefully we can reach resolution in parallel with actually using this thing. May try to fold in some editorial clarifications and refactor the document slightly. A number of people have filed issues regarding sort of organization of the document. So we're going to try to do a careful we may try to do a careful, pass over it to make it more friendly to implementers without hopefully breaking anything or introducing any wire format changes. We'll see how much work is actually to be done there. And MT, I may reach out to you since you went through the similar exercise with Quick long ago. After we do this and publish the next version, I guess we could start some test deployments and interop, see how things look, and then revisit basically in the next IETF or whenever we've had enough time to let this bake. And I think that's pretty much it. Stephen, go
ahead. So I'm just wondering, are we going to do a working group last call on this? And I just have a local reason for that, is that I have some funding to write this code that might come to an end in the meantime, and it would be good, say, for me, to say there was a working group last call that matches that. And I don't know if that would be generally good for people.
I guess I'll punt that to the chairs.
My question, I guess, would be, what would be the semantics of that working group last call, given that we just agreed to punt a bunch of issues which people don't agree on? So, like, would be like, we agree, but module all of these changes that we have not decided to make. What would be the semantics? Like, if we do working group last call, Stephen, what would you say about extensions? And then what would we do with that information?
So what I'm asking for is just a purely local thing, and it's independent of that. It's just to have a checkpoint I can map code to.
Oh,
and I can
okay.
Better if it's working group last call. That's all.
I have no problem with it. I mean, I think if we can agree to like not fight about the things we agree not to fight about, I think having some sort of call for like other issues would be great.
So it's probably easy enough to write a working group last call that carves out certain issues that we've obviously punted on, that we've talked about during this session, and I can work with Chris to make sure that we document that. And we'll try to share it around with everybody who's been involved to make sure that we're not tripping over anything, and then get it out to the working group. Does that sound like a good way forward? Thanks.
Okay, unless there's anything else, I think we can call it. Just wanted to say thanks to everyone who helped and contributed in one way or the other to get us here. I think what we have right now is a good protocol, albeit somewhat complex, and hopefully this is the start of ECH. So with that, I will stop sharing. I don't recall who's next on the agenda. Nimrod, okay. Do you want to request slides?
Yeah, I thought I requested them. I'm not sure what's supposed to. Oh, thanks.
I had to click a button. Okay, take it away.
Sorry, just adjusting the camera. All right, thanks. So my name is Nimrod Aviram, and with moral support from Carrick and Chris, I'd like to deprecate obsolete key exchange methods in TLS. So what this document does is it deprecates RSA key exchange and limits FFDHE to only to reasonable groups with sufficient security. As a reminder, we already have a separate document that says if we do use FFDHE, it must be full ephemeral, and we can't use static finite field diffie element. Now, to preempt a question, yes, this would be fully practical, and in fact, it's consistent with Mozilla's server-side TLS guide. As the Mozilla folks note in this guide, this would be compatible with almost every client released since around 2015. Now, why should we deprecate RSA key exchange? Honestly, because it has been a foot gun for many years now. It doesn't provide forward secrecy, and these cipher suits are already marked as not recommended. RSA key exchange has continually suffered from Bleichenbacher's attack over the years, where we had 2 major ones in the last 5 years alone, and more throughout the years. And this attack surface is shared across all servers with the same key. As to FFDHE, you can use it securely, so the document requires just that. There's no mechanism to negotiate the group size, and this is a known problem. But if you use a well-known group with length at least 2,000 bits, this is okay. Using smaller groups or reusing ephemeral secrets or using weird groups are all not okay, because they have been shown to either weaken or break security. So the document disallows these practices. So again, we're talking about deprecating RSA key exchange and limiting FFDHE only to reasonable well-known groups, and this would be widely compatible. And before I take questions, I'd like to preempt another question, where people on the mailing list have argued that this would be incompatible with some market niches. And I think if that is the case, we should have before us concrete evidence as to why this would be incompatible and in which specific niches. And like as another point to consider, I hope we all agree that we don't want to have RSA key exchange around in, say, 2030, right? So we are planning to deprecate it. So if not now, what is the plan? How are we going to deprecate it? I'm in favor of deprecating it now, to be clear. That's it for me, and I'm happy to take questions. Anyone?
Nimrod, I think you could just run the queue.
Yeah, Victor, you're up first.
Okay. So I'm the maintainer of niche implementation, which is Postfix, and there are various other SMTP servers in the same boat. Postfix has a compiled in, generated by me, strong group as a default. It has no knowledge of any of the well-known groups, and it's widely used. And it will take a while before servers would be updated, even if I were to ship a new version of Postfix tomorrow that only use the well-known groups. It'd probably be 5 to 10 years before that version becomes dominant. So if clients stopped understanding the FFDHE, one might hope that ECDHE would be sufficient, but I expect interop issues if we drop support for ad hoc FFDHE.
All right. So first, nice talking to you again, Victor. Can you elaborate on this group? Is it like a safe prime?
Yeah, it's a Sophie Germain safe prime, yes.
So like off the top of my head, it sounds like there is a case to add to consider this a well-known group after careful analysis. So if it's that prevalent.
Users are also encouraged to generate their own, and many do. So lots of servers have just custom DH parameters. The same applies to XIM, not just Postfix. I think the SMTP space is very different from the web space. And there are probably other applications in the same boat.
I see. And do we have assuming we don't deprecate, we don't limit FFDHE to well-known groups now, would we have a way to get metrics for this? So we know when we can deprecate it or limit it to groups?
Good question. I can put out new code, and it will take, as I said, roughly 5 to 10 years before at least the Postfix ecosystem is no longer typically doing that. I don't know how long XIM, and I don't know about applications outside of SMTP. Other people would have to speak to those niches.
All right. So, like to summarize, I think so. We can expect interop problems for SMTP, and at least it's on the open internet. So we could expect to gather some metrics as to where things stand. Do I get it correctly?
I mean, in practice, probably ECDHE is maybe preferred by implementations. Maybe it's more commonly used. It's hard to collect metrics on how common that is. Why
would it be hard to collect metrics? So as an academic, this sounds like a scanning paper to me.
Yeah, I don't have the resources to do that. Maybe Gmail can report that kind of data. I don't know if they collect that information or would be willing to make it available.
Yeah, we also have like specialist researchers who are very capable in collecting these metrics. I see we have a queue, the queue building up. So maybe I thank you again, Victor, and get to the next question, if that's okay. All right. Yeah.
Sorry. Thanks so much for giving this presentation. I actually had a follow-up question for Victor. He was saying that they're going to need this for 5 to 10 years. I was just wondering, like, what exactly is? Sorry if you already mentioned this. I don't think you did. But what's going to happen within those 5 to 10 years? Like, are people in the midst of like planning to upgrade within 5? Like, what exactly is like? Why not 3 years? Why not 20 years?
It's the upgrade cycles for SMTP are much longer than for browsers. This is server infrastructure that people deploy and then don't touch for half a decade or more.
Okay, thank you.
David Benjamin, why don't you go ahead?
Yeah, so I am extremely excited about getting all of these things out of here. One thing I would caution, though, on the FFGHE side, so for TLS-12, we kind of screwed up the way we defined the named groups. There is no way for a client to say, I support DHE, but only with well-known groups, because we use the same cipher suites for the server-chosen DHE and the well-known group DHE. So this is one of the reasons why, like, Chrome and anything using boring SL does not support DHE ciphers at all anymore, because when we were trying to raise the bar from 1024 to 2048, there was no way we could like say this in the client hello, and so you end up with a situation where the client wants to support DHE but only with these groups. But because it can only say I support all of DHE, the server is totally the server is completely within the server's like right to pick a tiny one, even though there is, and then we would break, even though there is actually another key exchange that it supports that we would have been okay with. So we may have some difficulties, like clients that haven't gone all the way to remove DHE altogether from TLS-12 may have some difficulties saying this.
And do we expect like a lot of interrupt problems if we make this limitation?
I have no data on this because I just took it away altogether. But I guess it's probably a question of like, so of the servers that today negotiate DHE ciphers, how many of them are sort of on accident already the groups that we like? Because effectively what we're saying is like, we're going to let the server pick, and like if it accidentally picked the right one, then we're happy. And at the time when we were looking at it, it was like 95% of servers chose the 1024-bit group, and so we were like, this is not worth trying to salvage at all. It's possible that in those intervening years, the ecosystem has shifted a bit.
All right.
Let's say we cut the line after. The line after.
I'm not sure how these things work.
Yeah, just keep going through the list. No one else is going to get in the queue. So when we get to Chris, then we'll close it out.
All right. Scott, please go ahead.
Yes, I'd like to bring up a possible compromise to deal with Victor's scenario. One possibility is that you actually allow server proposed parameters, but the client make it mandatory for the client to check to see if the prime specified is in fact a safe prime, which can be done. It's not particularly cheap, but it can be done. And as long as the generator is between 2 and p-2, you're safe.
Sounds like a good idea. I'm in favor, and to be honest, I think Amazon S2N does this. On the rare occasion it needs to negotiate FFDHE. So yeah. Rich, please.
Hi. So the issue that Victor brings up is a regular problem here. We want to move the industry forward, and there's always some community that can't because of enterprise issue deployment issues. I used to work at IBM where they had software older than I was in production. Too bad. We should do the right thing. We should do the thing that's more secure. And if there is a community that can't follow this particular RFC or standard, if it becomes that, so be it. There's no requirement. Nobody's got a checkbox that says, oh yeah, you're not RFC 101110 compliant. That's not what auditors and so on look for. right? They look for other things like PCI compliance and so on. So I am sympathetic to postfix. I think Victor's joke about a niche implementation was kind of funny, but it shouldn't stop the whole rest of the world from moving forward. Also, isn't SMTP world still mostly opportunistic encryption? So yeah, that's all. We shouldn't let a particular community hold back the security of the rest of the world. Thank you.
Thanks. Yeah, Ben, please.
Just to basically say the same thing, this is probably a case where we can go ahead with our proposal, but we can do our best to document known limitations and cases where you won't be able to do exactly what we say. This may still be the best general purpose guidance, but if you know of some mitigating circumstances that make it not the best guidance, then of course you do what's best for your case.
Yeah, all right. Chris, please. Christopher?
I was just going to mirror what Benjamin and Rich said, so I have nothing to add.
All right, thanks. So as an IETF node, it sounds to me like this has kind of support, doesn't it? Would the chairs be so kind as to summarize how should we proceed?
Yeah, I think we can do a call for adoption after the meeting and hopefully move forward.
That sounds good to me. All right, unless, does anyone want to add anything? All right, so thanks everyone for your time. Thank you.
All right, thanks, Nimrod. All right, here we go. Sophie, pulling up your slides.
Okay. So
All right.
I guess everybody's seen the slides, right?
Yes,
Yeah.
take it away.
Okay, so hi everyone. My name is Sophia Selly and I'm a cryptography at Cloudflare. I'm joined today with Tom Biggers, a cryptographer as well from Radboud University. And today we wanted to talk about a new mechanism for achieving authentication in the TLS 1.3 handshake. And if you want to find more details about it, please go to the draft that is listed in this slide. Okay, so basically how one achieves authentication in the TLS 1.3 handshake, as we all know, is that you have to prove who you are, and you prove this by showing possession of a private key. Most of the times, specifically in certificate-based authentication context. You manage to have authentication in TLS by what I said, signatures of the certificate key in a certificate-based context, or knowledge of a pre-shared key, or password-based authentication. And today we want to talk about a new way, which is authentication by a key encapsulation mechanism, and its acronym is KEMS. So how does this mechanism work? It's basically using this algorithm that I just told you, the key encapsulation mechanism, which had two important algorithms to use, which is the encapsulation one and the decapsulation one. So what happens is that, for example, if a client wants to talk to a server, instead of sending a signature, what we'll be sending, it will be sending a certificate with a long-term public key. And then the client, in this case, Sophia, in this case, myself, will do an encapsulation towards that long-term public key. The result of that operation is going to be a ciphertext, which is the enc, and a shared secret, which is the SS. That ciphertext is going to be sent in turn to the server, which in this case is Tom. And if Tom is able to decapsulate and arrive to the same shared secret that is going to be used to derive all of the handshake all the handshake secret keys, then indeed you're assured that you're talking to the right entity or to the right person. How does it look compared to TLS? In TLS 1.3, it's now on the slide in the left, and on the right you see the modification of auth-KEM if you're talking only about server-only authentication. In the case of server-only authentication, then what you will be having to send is, of course, is this KEM encapsulation, after the server has sent the certificate. For server-only authentication, this adds only an extra half round trip from the point of view of the server, because the client can send immediately application data in the same ways as TLS 1.3 does. In the case of mutual authentication, there's an extra full round trip that gets added because every entity has to send the key encapsulation as a result of the certificate that got sent, of the long-term public key encapsulation of the certificate operation, and therefore this extra round trip gets added in comparison with TLS 1.3. Tom, could you talk about the security considerations of this mode?
Okay. So we send data before the server has sent the finished message, because otherwise you get into a 2 round trip protocol and you don't want that. So is this okay? And yes, we think this is okay, because although the cipher suites are not authenticated, the client must anyway be confident in its selected cipher suites, and any handshake that you would try to do anything messy with the server's cipher suites, such a handshake could never finish. So any attack that might want to downgrade to, I don't know, AES 128 would never finish successfully. So I don't think this is a risk. Any application data that is sent before and after the server's finished message is received retroactively also receives strong downgrade resilience and full forward secrecy. Back to you, Sophia.
Okay, thank you, Tom. So in case also that this extra round trip is also way too much, there's also a version of the AuthChem which reduces quite significantly this extra round trip that gets added, and is basically using the knowledge of any pre-distributed material, basically any pre-distributed certificate or any way to find the long-term public key that the server or the client is using. In the case for server-only authentication, what happens then is that this key encapsulation message gets sent along the client hello, either as an extension or as a separate message, and immediately the server can send application data in the same way as TLS 1.3 does, and the client, of course, can send application data the same way as in AuthChem or TLS 1.3. For the case of the server, for the case of mutual authentication for the client, this sometimes happens in the scenarios where you already know that the server is going to be asking for client authentication prior to. So you will be sending the certificate of the client alongside in the client hello, and this is going to be encrypted by the shared secret that is derived of the encapsulation mechanism. And in that way, you also reduce the extra round trip, because you're basically able to send application data in the same way at TLS 1.3, at the same point that TLS 1.3 does. This also has security considerations, of course, because the encryption of the client certificate, if one follows the TLS 1.3 guidelines, has to be sent encrypted, the client certificate, for privacy consideration. But this is in the current AuthChem is not encrypted under the forward secure key, so it has similar considerations and trade-off as when sending zero RTT data. And of course, you have to be sending encrypted under a cipher suite that you think that server will accept. Of course, this will not always be the case because, for example, from Cloudflare data, we only know that less than 80% traffic actually use a resumption mode or a cache mechanism. So there will be some cases in which this pre-distributed mode will not fit. And now you go.
Yeah, so this is all a lot, and we realize that. You have new handshake messages, new authentication algorithms. You're moving your handshake state machine a bit closer to TLS 1.2 again, where the client's finished message is sent first. And we also need to make changes to the handshake key schedule, because you need to send, for client authentication, you need to make sure that's sent encryptedly, and we need a new handshake, an authenticated handshake secret for that as well. So this is a lot, but why do you want to do this then? Sophia? This allows you to use the same algorithm for key exchange and authentication. So it pushes signing algorithms out of the TLS stack for the handshake And that can also, for example, save you a lot of space if you have an embedded device where your code size is really at a premium. It also works very well with, for example, delegated credentials with Diffie-Hellman keys or certificates with Diffie-Hellman keys, as in the kernel PKIX draft. And we have also academic work that goes into all of the scary crypto bits in much detail. So we want to point for that also to those papers. Why don't you use draft semi-static? Well, this is leading up into the real motivation of this proposal, and that is post-quantum cryptography. Draft semi-static is very exciting. It's also known as the OP-TLS proposal, but it requires non-interactive key exchange. There is no usable for TLS non-interactive key exchange at this moment. Psych is very slow. Its security level at Psych, sorry, not Psych. Psych is not Psych as a chem. Seaside is a non-interactive key exchange, and it is very slow. Its security level is still uncertain, and it might get much bigger at realistic security evaluations. Next slide, please. Post-quantum chems and signature schemes are coming. Authentication via chems is much smaller, and for the signature schemes, we've seen that there's very few suitable choices. Only really Dilithium and Falcon will fit in a TLS handshake. See the paper by Dimitris and Panos and, sorry, I forget the third author. They have larger public keys and signatures than chems have, public keys and ciphertext, slower operations, and for example, especially Falcon needs floating point hardware to really work quickly. Next slide, please. So we have a overview of roughly the sizes here. And you see that especially Kyber and the Lithium are leagues apart in terms of the size that you send over the wire. And that is at Kyber 512 and the Lithium 2 are roughly AES 128 in terms of security. If you go up to higher levels, they go even further apart. Falcon indeed is roughly the same size as Kyber, but Falcon needs a lot more computation time. And if you don't have AVX2 code, it is rather slow, as also pointed out by the paper linked in the previous slide. The draft right now uses pre-quantum HPKE to get this conversation started. But obviously, we want to move to post-quantum as soon as that is available. But we think it's very important to start this conversation right now. What about this? It seems like we have, we not yet have post-quantum HPKE. Hopefully soon. What about this extra half round trip? We argue that the client can still send its HTTP request or any other request to the server at the same point as in TLS 1.3. We have tried to think about it, but we could not really come up with any application where a server sends data before the client has asked the server for what it wants. And I'm probably going to be corrected here, but in most applications, I think the client needs to send something first, and we make sure that in the simple server authentication case, the client can still send its request in the same place. And we have experiments both on real networks and a lot of simulations where we see that AuthChem should perform as well as doing a signed key exchange. But many, many more experiments need to be done. We try to keep this a little bit short for questions, so we have time for questions, and also a lot of nitty-gritty stuff was glanced over because of space. So also see the draft. We don't expect to be finished in a single iteration, of course.
Let's go for questions.
So we will go for questions, but before we go there, we'll let you guys manage the queue, but we're going to cut it after Benjamin Schwartz because we have other presentations we want to get to. And obviously, we'd like to see the stuff moved to list. Thanks, Panos.
Okay, Victor.
Comment, SMTP, of course, the server speaks first, but it's not latency sensitive. So even if it slows things down, SMTP is willing to tolerate the cost.
Yes, thank you for pointing out. Eric.
Presentation. So I sent some comments to the list. I guess my view would be probably characterized as this seems premature. This is like an enormous change. And like, one of the things like we did in 1.3 was try to standardize on exactly one set of handshake flows that were based on Diffie-Hellman and their analogs. And as far as I can tell, like the entire rationale for this is a performance difference between signatures and chem. And like, it's 2021 and we're like 5 years away from like post-quantum authentication algorithms being like useful in any meaningful kind of way. And so like on a good day, you need a post-quantum PKI, let's start with that. And so, it took us like, we don't even have like ED25519 in our sorts. So I think like to massively re-architect TLS in order to like accommodate what is really quite a modest performance improvement is really not worth doing. In particular, like I've seen this data on the sizes I indicated in my email, like this is not the limiting factor, like increase your TCP handshake window or a quick amplification window and you'll get most of the way there. And to the extent to which we have a problem that size, it's gonna replicate the cert chain and the signatures in the cert chain anyways. We have to solve all these problems in the first place. So like I think yeah, I think this is interesting, but I think like it's kind of like if you can't figure out if the TLS going through handshake skeleton, it's gonna be a pretty big lift.
Yeah, maybe if it takes so much time, then it's also good to get started now. Chris.
Hey, I just want to say I support this idea. It seems to me like it was the dream of OPTLS, but they didn't use the right abstractions at the time. And I think the chem abstraction is a really useful way to model it just makes it easy to me. It's a nice abstraction for reasoning about the security of a handshake. But I kind of agree with Ecker. I don't know if you can put this in TLS 1.3 as a practical matter, but is this something that we want to do for TLS 1.4?
Thank you, Chris. I guess the last one is Benjamin.
Hi, Ben Schwartz, Google. I wanted to ask about, I thought I heard maybe Tom say that the standard handshake maintains forward secrecy. Does that assume an ephemeral server public key?
You still need a key exchange, ephemeral key exchange just as normal, and the authentication part would not be ephemeral. You would have a long-term server public key or client public key. That is a chem public key.
I guess I'm trying to figure out what the forward secrecy guarantees are, because it seems like somebody who holds the server's long-term private key can decrypt the handshake and get the shared secret if the shared secret is just generated by the client.
Yeah, but the shared secret is mixed into the full key schedule, so all the ephemeral data is also in there. And actually, to break the shared secret, that the main secret that comes out of the handshake at the end, you would have to have both the ephemeral key and the server's long-term key. So in that sense,
Okay.
It's even slightly better than the normal case.
Okay, thank you.
It's like a ticket to the list kind of discussion. So thank you very much for your time. And we're going to move on to, I think, is Owen going to do it or is Dan going to do it? You're up, sir.
Okay. Okay, so I'll be really quick. We don't have much time. So an update since IETF110 and draft 02. So as agreed in the mailer straight after the last presentation, we've done a refactor of the crypto in the draft. We're no longer using draft J-Highland TLS extended key schedule. We're no longer injecting additional static ephemeral ECDH key pairs into the key schedule instead. We're deriving a PSK from the DPP bootstrap public key. We're using RFC 8733 as is. We're using RFC 7250 as is. Server is going to prove knowledge of the bootstrap public key via PSK, and the client is going to prove knowledge of the associated private key using RFC 7250. So we discussed this in the mailer with Ecker. So a subsequent bootstrap key pair can be used to authenticate the supplicant to provision against the Wi-Fi network. It gives a guarantee to the supplicant that it's connecting to a network that knows its public key. It gives a guarantee to the network that the supplicant that is connecting knows the associated private key. The trust bot model is based on knowledge of the bootstrap key. So the bootstrap public key is assumed to be secret and known only to the owner of the network operator. The key, it's encoded using ASN1 sequence of public key info from RFC 5280. It's a raw key pair. It doesn't have to be part of a PKI. It may be static. It may be embedded in the supplicant, maybe printed on a QR label, included in a BOM, etc. And we want to reuse that bootstrap public key for Wi-Fi onboarding. We want to reuse that for wired onboarding inside an EAP exchange. So it's a high-level flow of the the wireless exchange. The supplicant will do a chirp, which is a hash of its public key. It will broadcast that. A network that thinks it knows the full public key will respond. And step 2 here is the important thing that we're trying to do inside the TLS handshake. A DPP authentication exchange will take place. As part of that authentication exchange, the network will prove it knows the supplicant's bootstrap public key. The device will prove it knows the associated private key. In step 3, DPP allows provisioning of any credential that is needed for network access. So we will, for this use case, we'll do provisioning inside an EAP. And then after the exchange is completed, the supplicant that has network access. So these are the changes. These are a bit more detailed in the changes since the last draft. The bootstrap key is used to derive 2 pieces of data. An identifier, which is used to signal the bootstrap key for PSK, and then the actual PSK itself, which is used for authentication. We use 8773 as is, which is a cert-based auth with an external PSK. And we use 7250 as is, the raw public keys. We use a raw public key so that the client can prove knowledge of the bootstrap private key. And we also propose using draft group TLS extensible PSKs. And we want to use that to define a mechanism for specifying it's a derived PSK from a DPP bootstrap key, and also just to signal the identity. So no TLS changes or extensions are required over and above defining the new BSK type for that draft TLS extensible PSKs. This just shows how this fits into the handshake, and the only change we're proposing here now to any of the drafts is to define a new extended PSK type. And we're reusing the circuit external PSK as is. We're using the raw public key client cert type as is. And so what this will enable us is if we have a device or a thing that has a bootstrap public key, a DPP bootstrap public key, and whether it's printed on a label on the device itself or whether it's included in a BOM or downloaded from a cloud service, and we'll be able to reuse that same public key for bootstrapping the device against both a wired network using EAP and a wireless network using DPP. Spec is there. There is running code for the TLS part of it. We did present this at EMU at IETF111. There was interest in progressing it. Based on that, we presented a TLS and got some good feedback on the crypto mechanism. And we are presenting this again at EMU on Thursday. And that is it.
Comments, questions? All right, Ben.
Sorry, I was about to type this in the chat, but I figured I should ask in person. Thank you for this. It sounds much improved. I didn't quite get, just from the brief presentation, what the need for the extend PSK extension was, but I should probably either read the draft or take it to the email list. So thanks again.
Well, the extended PSK allows you to define what type of PSK it is, and we thought that because we're deriving the PSK from a BSK, it's useful to make it very explicit that this is a derived PSK that we're deriving from a known and provisioned BSK.
Thanks, Owen. I took a quick look at this earlier today. This seems like more along the lines of what I was expecting, but I haven't really studied it.
Okay.
Can you say a little bit more what you were hoping the outcome of this discussion would be?
Well, we think because we're not making any changes, not really making any changes to any TLS handshake at all, really. This is just to have a review here, but I think we can probably progress this in EMU working group alone, I think. But because we got such strong feedback on the previous proposal, we wanted to run it past the TLS working group again, but we think this lives in EMU now. I would like to get your feedback on that.
If EMU wants to take it and go forth, I think that there's no real concern with that happening. I mean, there's obviously been some cross review when things go to working group last call. I mean, there's no requirement that like extensions or whatever codepoints that get assigned must be done in TLS. They can, many of them can be done elsewhere. So unless we're hearing any violent objections about adopting this now, I think EMU is the way to go.
Yeah, and as EMU co-chair, I think we'll have a presentation, discuss this tomorrow. So.
Okay.
Benjamin, do you have a additional comment?
Yeah, just quick question, hopefully. So I may have missed this from the slides. Is there a reason you all need to authenticate the server based on knowledge of a secret public key? So it's like the public keys are generally treated as public. Like when we write when we like worry about side channels, we just side channel protect them and such.
So well, this is the way that the Wi-Fi Alliance DPP. Where's the slide here? This is the way that the Wi-Fi Alliance DPP protocol works, which is you have a bootstrap public key associated with, say, a light bulb or whatever, right? And the public part of that key is printed on a label if something is cheap, or else it's included in a bomb if you want to have a bit more protection of it. But you the bootstrap. It's not a certificate that's used, a full certificate that's used for like a TLS handshake. It's in the DPP protocol, it's a public-private key pair with the public part printed on the label, and the way you provision the device against your Wi-Fi network is a configurator, which could be an access, could be your could be an app that's linked to your AAA, and you will scan or provision the public key, and the network needs to prove it as knowledge of the public key back to the device. Which means that you can't send the public key in clear text over the network to the network itself.
Yeah. So this is an existing thing where you already have like these secret public keys printed on, I guess, the rubber duck, and so yes. You're sort of stuck with because like if we were sort of doing this without that legacy, like I imagine you would want to have that be a thing that is actually consistently treated as secret by all of crypto libraries, and so like maybe it'd be a public key with like an HMAC or something, just with like a some sort of PSK key that you could swizzle into stuff.
But it's an existing Wi-Fi Alliance standard.
I think we're going to move on to that's Martin Thompson's SNP presentation. Thanks, Owen.
Thanks.
Audio work.
Great here.
Who knows how these things work? Okay, this is a very short presentation because we don't have enough time. So the problem that arose here is that we have two incompatible protocols that achieve the same basic goal. And canonical example here is HTTP2 and HTTP3. You can't really try to get one if you start to attempt the other. So this is a really simple extension now. The client says that it supports the extension. The server lists all of the protocols that it might have that aren't compatible with the current one. And if the server would have, if the client rather would have preferred one of the listed protocols, the incompatible ones, then maybe it might do something. Maybe it considers this as an attack. Maybe it just tries to attempt to connect with that other one. It's going to be up to the client as to how they react. So the TLS bits are exactly that simple. They borrow ALPN. And when I last presented this, it was far more complicated. Thanks to Ben Schwartz here for talking me down from the ledge. And the only thing here that really changes is that the scope over which a server is claiming to support a particular alternative protocol is essentially just IP plus port. And at that point, it has relatively limited applicability, but I think it will be applicable in a lot of the cases that people care about quite a bit. And it won't run afoul of some of the multi-CDN deployment scenarios and all the complex deployment cases that people have in deployment. And so it's much less likely, I suspect, to run afoul of just not being usable in a certain deployment. Key point here is that it doesn't really care what sort of discovery mechanism you use to find the server. The assumption here is that TLS is authoritative for information about what protocols are supported. The basic model that we're adopting here is that the server chooses between compatible protocols. That's the existing model that we already have in TLS and ALPN. But the client chooses between incompatible protocols, and it kind of has to do that because only the client chooses what protocol to attempt to make. And the other thing that relates to this is that the client has to be the one to then decide what to do if it finds that maybe there's been a downgrade attack or something like that. And there'll be a number of different ways we deal with this. One of the potential ways in which we might do something like this for Quick is that the clients might find that on some networks UDP is blocked, and so they can't uniformly say that if you have no UDP access, then this is a downgrade and it's an attack. You have to sort of tolerate, to a certain extent, networks that block UDP and deny your access to HTTP3. On the other hand, if you're in an environment where you have successfully used HTTP3 and you find that a server says that it's got HTTP3 and you weren't able to establish an HTTP3 connection, that might be treated as an attack in that case. And there's relatively minor constraints on how servers deploy this. If they use this extension, they'll need to ensure that things that share an IP and port don't have incompatible configurations. That is, one port can't advertise the availability of something, or say your quick side advertises the availability of HTTP2, you actually have to have HTTP2 on the TCP port. And that's it.
I'm generally in favor of this, but I have I think it's a clarifying question. If you are doing if you have any cast, then everyone in any cast group has to have the same configuration, right? So you can't otherwise it's good. Kind of okay. That's what I assumed.
Yeah.
So don't do that. Don't do that then.
Yeah, my assumption in these cases is that the way that you would do this is you would deploy the alternative protocols and you would have that as consistently available, and you'd be fairly confident in your deployment of, say, HTTP2 and HTTP3 across that entire Anycast deployment, and then you would turn this capability on. One of the things about this is it's kind of discretionary when you use this extension. If you're not sure about it, don't use this extension.
Right. This is the same kind of like two-phase commit as QuickVN, as the QuickVN draft.
It's a little less complex than the QuickVN draft, but yes, basically. It's the same design.
Yeah, seems good.
Ben Schwartz, Google. I support adoption.
And on that note, after Rich, I think we're going to cut the line, but on that note, I think we're going to try to run some polls, or Chris is going to try to run some polls. Thanks.
Thanks.
Yeah, hi, thanks. I really appreciate the simplicity. But could you give me an example of what what protocol numbers, protocol names on port 443 a server might send back?
The canonical example here is HTTP2 and HTTP3. So if you've got a quick deployment, you want to make sure that clients are aware of the fact that you have a quick deployment. And without this, there's the potential for someone to block access to your quick deployment or your HTTP3 deployment and force you down to the TCP-based design, which has maybe less security than the quick design. And so you use it for that. Now, of course, you could use it for other things as well. I tried to make it generic, but that's my primary motivation here.
Okay, I guess I was misled by the incompatible use. Okay, thanks. Makes sense. I support adoption.
Okay, thanks, Martin. Very quickly before we do a poll, just to kind of get a rough sense of whether or not people are interested in adopting, can I just get like a +1 if you read the draft in the chat? Whole numbers only, please. Okay. All right. While that comes in, I'm going to throw up a poll to see if this is something that people would like to adopt. So let's see, you should have, if you go to the poll in the top right, you should see the question. Should the working group adopt this draft? We'll let it run for just a little bit. Okay. End it. In the interest of, I guess, fairness, we'll ask the opposite question. One second. Just simply the inverse. Go ahead, Edgar.
Holy, do not raise hand if you want the draft, so we're not crazy.
Right.
Let us not have like some really mixed result here.
Okay, this seems fairly consistent. Do the people that do not want to adopt it, do they want to say anything at the mic? Yeah, Stephen?
Yeah, I'm nothing against it. I just haven't read it. I think it's interesting that 19 people want it and only about 7 or 8 read it. So doesn't sound crazy, but maybe not quite yet would be my answer.
Gotcha. Okay. Thank you. All right. As always, we'll confirm on the list. I guess if there's nothing else, perhaps we can call it early. Or actually, we're over by 1 minute. I'm sorry.
That's not bad. I mean, we're pretty good for only being a minute over.
Yeah, exactly.
All right. Thanks, everyone.
Yes, thanks all.
See you next time.
For you.
Yeah. Bye. Thanks.